Warahmatullahi wabarakatuh dan selamat petang kepada semua pelajar-pelajar CS249. CS249 ni adalah pelajar-pelajar matematik ya, dan semester daripada semester ke-6. Okey, semester terakhir, semester hadapan mereka akan menjalani latihan industri. Okey, untuk semester yang ke-6 ini mereka didedahkan kepada mata pelajaran Graph Theory and its Application ni untuk kurikulum UiTM bagi program matematik. Jadi saya mengharapkan dengan webinar petang ini dapat memberi sedikit sebanyak input tentang another part of knowledge of graph theory. Okay, sebab dalam kurikulum graph theory di UiTM dia lebih menekankan kepada aspek application. Jadi saya mengharapkan mereka akan dapat sesuatu daripada webinar petang ini. Okey, untuk makluman semua, selamat datang kepada Dr. Roslan Hasni di webinar online. Dr. Roslan Hasni adalah UiTM Fellow Bersekutu untuk Fakulti Sains Komputer dan Matematik yang sekarang ni telah dikenali sebagai KPPIM, College Pengajian Perkomputeran, Informatik dan Media. Okey, untuk pengetahuan semua, Dr. Roslan ini telah berkhidmat pada asalnya di USM daripada tahun 2005.
2005.
Daripada 2005 di USM dan join Universiti Malaysia Terengganu pada 2012 hingga sekarang. Betul ya Dr. Roslan?
Ya.
Okey. Kemudian bidang Dr. Roslan adalah graph theory, iaitu yang berkaitan dengan chromaticity of graph, domination of graph, graph labeling, graph polynomial, Hamiltonian in graph, chemical graph theory and nutrosophic. Currently, Dr. Roslan work out on nutrosophic graph theory. Betul Dr. Roslan?
Betul, sikit-sikit lah.
Sikit-sikit lah, adalah sentuh sikit-sikit. Jadi mungkin pelajar-pelajar tidak berapa familiar dengan term-term yang saya cakap tadi. Mungkin ada satu dua yang kena sikit-sikit lah contohnya. Mungkin pelajar saya ni pernah dengar tentang Hamiltonian graph. Tapi mungkin dia orang tak tahu detail on Hamiltonian graph. Dia lebih kepada application of Hamiltonian graph sahaja. Jadi itu sedikit latar belakang speaker kita petang ini untuk pengetahuan pelajar-pelajar. Jadi ambil peluang ini untuk mengetahui lebih lanjut. Kalau tak dapat 100% pun pengetahuan tapi dapat sedikit touch you punya heart on graph theory, dapat tahu sedikit on the theoretical part adalah amat bagus untuk you all punya pengetahuan ya. Jadi tanpa membuang masa, sebelum tu saya perkenalkan kita ada asisten di sini, Dr. Normi. Dr. Normi yang akan membantu saya untuk pengendalian YouTube. Jadi Dr. Roslan akan lebih famous selepas ini sebab Satu Malaya akan lihat Dr. Roslan. Dr. Roslan membentangkan tajuk pada petang ini. Alright, so silakan Dr. Roslan. Live. Silakan Dr. Roslan dengan pembentangan tanpa buang masa. Kita ada dalam 1 jam, insyaAllah.
InsyaAllah.
Okay.
Saya share skrin dulu
Alright.
Boleh nampak?
Boleh, jelas.
Saya tak nampak. Okey. Boleh nampak skrin
Ya, nampak.
Tak apalah, kita tunjuk skrin dulu Okey, assalamualaikum dan salam sejahtera semua. Saya pertamanya saya nak ucapkan terima kasihlah kepada chairperson petang ni, Dr. Sumani. Tadi yang for the nice introduction Tapi saya ni kalau nak kata tak adalah hebat sangat dalam graph teori lah, tapi saya akan cuba share pengalaman lah. Share pengalaman dalam pendidikan saya dalam teori graph lah. Sebelum tu di partisipan petani semua ni yang kursus pelajar yang ambil kursus teori graph ke di UiTM?
Ya.
Okey. So saya cuba tak pergi secara mendalam lah. Saya cuba berkongsi sedikit lah pengalaman, tapi saya tak kesentuh secara mendalam lah. Jadi oleh sebab saya sebenarnya tak tahu juga nak share apa petang ni kan dengan pelajar ni. Saya tanya banyak kali juga dengan Dr. Semani, saya nak share yang research saya ke atau macam mana kan. Jadi saya terfikir inilah tajuk ni lah, Topological Indices and Domination Parameters in Graph lah. So ini kalau pelajar yang tak baru ambil, baru kenal graph theory, mereka mungkin tak berapa familiar dengan topological indices ataupun topological index and also domination parameters. Tapi tak apalah, saya tak akan pergi secara mendalam lah. Baik,
ada Dr. Zainuddin ada tu.
Dr. Zainuddin, kena ni in English lah. Dr. Zainuddin saya. Okay, hello Dr. Zainuddin. Tak apa. Okay, so okay lah, saya start. Let me start my presentation today. So the title is Topological Indices and Domination Parameters in Graph. So maybe some of you don't know me, do not know me. So I am Roslan Hasni from University Malaysia Terengganu, Malaysia. Okay, so let me start my talk with some motivation or history in graph theory. Okay, so anyone who refer textbook on graph theory, they will see the 7 Königsberg bridges. Okay, so graph theory started with Euler, who asked to find a nice path across the 7 Königsberg bridges. So the problem started where the people in this city were amused themselves, and they tried to find a walk where they can cross all the 7 bridges once and only once, starting from the same starting and ending at the same point. Okay, then this problem actually cannot be solved. Then somebody has shared this problem to Euler, Professor Euler. So Professor Euler tried to solve these problems, but he cannot find a solution for this problem, for this 7 Königsberg bridges problem. But then he put forward a notion of a graph or graph theory. Yeah? So someone said that this problem is actually a birth of graph theory. So someone also said that Euler is the father of graph theory, because he introduced the notion of a graph from this problem. Okay, then from this all 7 bridges or 7 Königsberg bridges, we can represent all the graph. We can represent this problem into the graph. So we obtain a graph here. So the Eulerian path should across each of the 7 bridges exactly once. Okay, so this is actually the idea of 7 Königsberg bridges problem. Okay, and then the second, the next history on graph theory is from Sir William Rowan Hamilton. Okay, another early bird in graph theory was Sir William Rowan Hamilton. So in 1859, he developed a toy based on finding a path visiting all cities in the graph exactly once and sold it to a toy maker in Dublin. Okay, Dublin is a city in Ireland, so it never was a big success. So this is the graph for this Hamiltonian graph. Okay, this Hamiltonian graph. All right, and then but now graph theory is used for finding communities in networks. So this again application of graph theory. So we can use graph theory to for finding communities in these networks where we want to detect hierarchies of substructures. So here we have like in the graph theory we call it as a subgraph, but in the communities in networks we call it as the substructures. Okay, so we want to detect hierarchies of substructures. Okay, so these are the short idea of motivation in graph theory. And then the size can become quite big. So we have a big graph, bigger graph. A big graph means we have many vertices and many edges. So in graph theory we call as dense graph. Okay, dense graph means the graph with many edges, many vertices. Okay, so this is a big graph. Okay, now in the modern graph theory, people study the following direction. Okay, the first is topological graph indices, chemical or social application. So topological graph indices, the topic that we are discussing today. So I will talk more on topological indices later. Then the networks and computer science, social networks, shortest path problem, traveling salesman problem, Chinese postman problems, and then neuroscience, fuzzy and neurosophic set. Okay, so we have fuzzy graph, neurosophic graph from the concept of a combination of concept fuzzy set, neurosophic set, and graph theory. Then we also have graph labeling. Okay, we can study graph theory by using the concept on graph labeling, graph domination. Okay, graph domination is a big interesting problem in graph theory, and graph coloring. Also, we can study graph coloring in graph theory, right? Then graph data structures, where that data is stored in a collection of interconnected vertices and edges, electrical engineering circuits, linguistic, passive and grammar of language tree, mathematical study of graph is always popular. Okay, so of course there are many more research direction in modern graph theory. So I just listed some of them here. All right. Okay. So here some basic definition and notation in graph theory. Okay. Of course, before we go further, we can understand the research in graph theory. We need to understand the definition or basic definition, terminologies and notation in graph theory. So so we have a graph G. So graph is ordered pair G. VG and consists of VG and EG. So VG is a set of vertices. EG is set of edges. Okay, so always when people talk about graph G, so we are talking about VG set of vertices and EG set of edges. All right, then the number of elements in VG we call as order, right? Then the number of elements in EG we call as size, right? Then a graph G is finite. A graph G is finite is the order and the size. Its order and its size are finite. So graph G is finite when when the order and the size of graph are finite. Okay, and then we also have the notion of the degree. So degree of V is the number of vertices adjacent to vertex V, okay, denoted by dV. Yeah, and then of course we have because the number of vertices or the degree of V is integer, so we have the maximum value of degree and the minimum value of degree. Right, so maximum we call as the triangle G, yeah, delta G, and minimum we call as delta G, yeah, right. Okay, and then we have also some example of graph like such as 3 unicyclic and bicyclic. Okay, of course, if you read book in textbook on graph theory, you have many more example on graph like star, complete graph, path, what else? Complete bipartite graph, okay, and wheel. There are example of graph. But also we have the three graph or just a three unicyclic, bicyclic, if the size is n-1 and n+1. Okay, for the for 3 the size is n-1. N is the order n. Order n means the number of vertices of graph G. So unicyclic, the graph is unicyclic when the size is n. The graph is bicyclic if the size is n+1. And then if the vertex V for which degree V is 1 is panda vertex or lift. And then we also have the concept of distance and the eccentricity. Okay. Okay, this is an example of eccentricity. Yeah, eccentricity for vertex A, vertex B. All right. So here for this vertex we label as A. For this vertex we label as B. This vertex we label as C. And then G here, this one vertex H. This one vertex F. So for this for all vertices we have eccentricity. Yeah. All right. Okay. So for further reading in graph theory, you can refer. For example, here you can refer graph theory undergraduate mathematics. Okay, so the authors are Professor K.M. Ko, Professor F.M. Dong, K.L. Ng, and E.G.T. Yeah, published in 2015, right? So Professor K.M. Ko is my external examiner of PhD thesis back to 2005. And then the second book, so you can refer is Introduction to Graph Theory, Douglas B. West. So I always suggested to students who are interested to do research or to know more on graph theory, they can refer the book by Douglas B. West. I think the book by Professor Douglas B. West is, as far as I know, is the best textbook on graph theory. And then other books you can refer is a first course in graph theory. The authors are Professor Gary Chetron and P. Zhang. And also, if you want to go for classical book, you can refer the book by Frank Harary, Professor Frank Harary, Graph Theory. So the book by Frank Harary was the first book I have been reading before doing my PhD. Back in 2001. Okay, so this is the book, Graph Theory Undergraduate Mathematics. Okay, this is just a front cover of this book. The authors are Ko Kim Meng, Fan Min Dong, Kah Lun Eun, and Eng Guante from Singapore. Okay. Alright. Okay. Now, topological indices in graph theory. Alright. So this is the topological indices. If we refer back title of my talk, one of the items that I will be discussing today is topological index or topological indices. So the first question is, what is topological index? Apakah yang disebut sebagai indeks topologi ya? So topological index is numerical quantity from the structural graph of chemical or molecular compounds. Okay, so it's very easy. So topological index is just numerical value or numerical quantity from the graph or from the structural graph of chemical or molecular compounds. Okay, meaning that if we have a chemical or molecular compounds, we can obtain the corresponding, or we can obtain the graph or the structural graph which correspond to that particular chemical or molecular compound. Then from that graph, we can find topological index. Okay, or we can find a numerical quantity correspond to that particular compounds. Okay, so there are so many topological indices. So they are used for quantitative structure property relationship, QSPR, and quantitative structure activity relationship, QSAR, right? Then topological indices have been successfully used for estimating several physical properties, okay, including normal boiling temperature and data related to biological activities as well. Because people may ask you about application of topological indices. Okay, so I would say that topological indices are used to estimate or to predict some physical or physical properties or physical chemical properties, including normal boiling temperature and data related to biological activities as well. Of course, if we want to know or we want to understand more on application part of topological indices, we need to do further research on its application, right? And then the best known such descriptor or the best known index is the Randy index. Okay, so for this Randy index, there are more than 1,000 papers. Okay, so untuk index Randy ini ada lebih daripada 1,000 paper yang study tentang Randy index. Dan there is ada buku, there is a book dealing with Randy index. Okay. But during many years, researchers were trying to improve the predictive power of the Randy index. So this is the application part of Randy index, application part of topological index. So some researchers were trying to improve the predictive power of the Randy index. Then this led to the introduction of new topological indices resembling the original Randy index. So banyak pengkaji dia nak improve the predictive power of the Randy index, but then suddenly people also introduce many new topological indices, okay, resembling the original Randy index. Maksudnya selepas diperkenalkan Randy index ini, ada banyak lagi indeks topologi yang baru yang diperkenalkan oleh researchers. Okay, kita akan lihat beberapa contoh indeks topologi selepas ini ya. So then people will ask why we need to introduce a new index. Okay, so the reason for introducing a new index is to gain prediction of some property of molecule somewhat better than obtained by already presented indices. Maksudnya banyak indeks ni diperkenalkan sebenarnya untuk mendapatkan nak predict, kita nak predict nak forecast property of molecule, or in this case chemical molecule, right? But then we need to do a test of study of predictive power of a new index must be done. Okay, so as a standard for testing new topological descriptors or topological indices, the property of octanes are commonly used. Okay, so we can find 16 physico-chemical properties of octane at this link, right? Okay, then after Randy index, Wukosevic and Fortula 2009 introduced geometry index or geometry arithmetic index denoted by GA index. Okay, alright. Okay, so this is some the graph for application part of topological indices, where in this figure they study the predictive ability of GA. So people compare the predictive power of GA index with Randy index. Then they test for 16 physico-chemical properties. Okay, this is the graph. All right, so I don't want to talk detail on application. Okay, again, this is some correlation coefficient for GA index and Randy index. Okay, all right, and then this is the Randy index. So just now we mentioned about Randy index. So what is the Randy index? So this is the formulation of Randy index. So as we can see here, okay, Randy index denoted by RG. So G is graph G. So it is a summation of 1 over square root of du times dv. So dv is the degree of vertices u and v. All right. So uv denotes the edge connecting these two vertices. Okay, so this Randy index was invented by Professor Randy, 1975, and then next index is first Zagreb index. So this one, first Zagreb index introduced by Gutman and Trinacci. Okay, 1972. Okay, this is the formulation of first Zagreb index. So M1G, M1G is the first Zagreb index. It is a summation D square V. All right, and then the second Zagreb index. The second Zagreb index, M2G is equal to summation dV, du dV, du times dV. Okay, so the second Zagreb index of graph D is was obtained by Gutman and Trinacci in the same year. All right, and then we have the geometric arithmetic index, GA index. Okay, so GA index was introduced by Professor Wukosevic and Boris Fortula, Professor Boris Fortula. All right, so this is the formulation of GA index. All right. And then recently the new index was introduced. They call as Sombo index. So just now the Zagreb is the city, city in Zagreb in Croatia, if not mistaken. Sombor, I think also a city in Croatia or Serbia, right? then the Professor Gutman, Professor Ivan Gutman. So Professor Ivan Gutman is the one of the top scientists, top mathematician in the world. I think his hash index is the very high. I think it's he's listed as the top, the top mathematician, the top scientist with a high hash index and citation. All right. So Professor Gutman is very famous in mathematical chemistry or chemical graph theory. Okay. So Professor Gutman pada tahun 2021, 2 tahun lepas, 2 years back, he introduced the new index, namely Sombo index, or in short, SO index. Okay, so this is the formulation of Sombo index, summation square of du square plus dv square. Right, this Sombo index. And then the very 2 years, also the same year, 2021, Professor Cooley from India introduced another new index, Nirmala index. Okay, this is a Nirmala index, summation of square root of du plus dv. Alright, so then I think some last week I was informed by my friend Dr. Akbar Ali about this new paper. Okay, if you can see here, this is a new paper. The title is atom bond some connectivity index. So these are the latest topological index introduced by this group of researchers. Okay, so Dr. Akbar Ali is my collaborator. Is from Pakistan. Professor Boris Fortula, Professor Ivan Gutman. Okay, they put forward the new index, atom bond sum connectivity index. So this index is actually a combination of atom bond connectivity index, ABC index, and sum connectivity index. Okay, so ada dua lagi topological index, iaitu ABC atom bond connectivity index dan juga sum connectivity. So this group mereka combine ABC dengan connectivity index, then they introduce atom bond sum connectivity index. Kalau kita lihat paper ni tahun lepas, publish tahun lepas. So this yang terbaru, topological index, the latest topological index introduced by researchers. Alright. So saya percaya selepas ni banyak papers banyak research yang mereka akan study atom bond sum connectivity index ni. Okay. Alright, so so kalau kita nak buat research dalam bidang ni, kita mesti tanya sebenarnya apa dia research problem yang berkaitan dengan theory of topological indices. So for the matter and more study problem in the theory of topological indices considered in mathematical chemistry, they ask for the aximal structures. Okay, aximal structures under certain constraint that maximize or minimize the given topological index. Aximal means you go for maximum or minimum. Okay, that's aximal structures means, right? Then we want to find the best possible lower and upper bound. Okay, so kita nak cari lower bound dan juga upper bound, batas bawah dengan batas atas untuk topological index topology. And then people also study interested with the relation between different topological indices. Okay, so means that kita boleh juga buat research tentang relation di antara dua topological index. Sebagai contoh, kita boleh kaji hubungan di antara Randy index dengan GA index, and then kita characterize the graph. So kita akan dapat equality lah. Kita akan dapat, and then daripada equality itu kita akan dapat dia punya apa? Kita boleh characterize extremal graph lah. Extremal graph tu maksudnya graph di mana kita akan dapat equality untuk upper bound dan juga lower bound. That's the extremal structure means, atau extremal graph, right? Then kita boleh study juga relation between topological indices with some graph invariant or parameters, alright? So ini yang last ini adalah apa? Penyidikan yang saya sedang buat sekarang ni lah, alright? Okay, domination in graph. So ada satu lagi direction. So kalau kita lihat tajuk yang saya share tadi, dia ada two keywords. The first is topological indices, then the second one is domination. Okay, so kita mesti nak tahu apa what domination means in graph theory, ya. So kalau nak tahu lebih detail tentang domination theory in graph or domination in graph, kena saya listkan di sini beberapa buku. Okey, buku yang pertama adalah ini, ya, Profesor Haynes, Profesor Hedetini, Profesor Slater, 1998, Fundamental of Domination in Graph. So kena baca buku ni untuk faham konsep domination in graph. Then yang latest ada 2020, ya, topics in domination in graph. Profesor Haynes, Profesor Hedetini, Profesor Henning, ya. Dan ini juga yang the third one is Roman domination in graph. So we can have a very comprehensive result on domination in graph, and we can understand the domination concept in graph by reading all this book. Alright. So the domination. Right. So these are so what is domination in graph? Right. So the problem of dominating the square of 8x8 chessboard is said to be the origin of the study of dominating set in graph. Right. So we have the concept of dominating set. So these are the definition of dominating set. Subset S subset of VG. VG is a vertex set of G, is dominating set of G if every vertex VG except S has a neighbor in S, or in other words, for every vertex V belongs to V minus S. V minus S means that kita ambil set V, kita delete set S lah. There exists a vertex U belongs to S such that V is adjacent to V. Alright. Then this is the dominating set. Then we have the concept of domination number. Domination number is domination number of G denoted by gamma G, ya, is the minimum cardinality of dominating set. Okay, maksudnya kalau kita ada satu graf, kita akan dapat beberapa dominating set. Okay, but the dominating set with the minimum cardinality contribute to the domination number. Okay, maksudnya yang dominating set tu yang ada minimum cardinality, minimum element, so itu sebenarnya adalah domination number bagi graf G. Alright, so kalau lihat graf ni, ni contoh. Tak sempat nak explain kot ni. So kalau graf ni ada satu graf di sini, graf G, kita label 1, 2, 3, 4, 5, 6, 7, 8 lah. Ada 8, there are 8 vertices. So set S ni 1, 3, 5. Satu dia can dominate, boleh dominate 2. Vertex 1 boleh dominate vertex 8. Okay. Then vertex 3 dia boleh dominate vertex 4. Okay, vertex 2, vertex 8 tadi dah dia tadi apa? Vertex 1 dah dominate vertex 2 dengan vertex 8 ni. So vertex 3 dia dominate 4. Okay, vertex 5 dia boleh dominate 7, dia boleh dominate 6. Alright. So set S135 ni adalah dominating set. So kalau untuk graf ni kita boleh dapat beberapa lagi dominating set, tapi yang minimum adalah set 135 ni, set S ni. Alright. So kita lihat sini adalah gamma set. Set S is a gamma set. So domination number gamma G adalah cardinality for set S, which is 3. Jadi graf ini domination number gamma G is equal to 3. Okay. Okay. Alright. Okay. And then from domination number, other variation from domination number, we call it as total domination number. Alright. So total domination number. So first we need to understand the total dominating set. Alright. So these are the definition of total dominating set. So subset S, subset of VG is total dominating set, abbreviated as TDS of G if every vertex G has a neighbor in S, and G must be isolated free. Okay, so these are the how we define the total dominating set. Right, total domination number gamma T G is the minimum cardinality of total dominating set. Okay. Alright, for the same graph, kita nak faham total dominating number kan. So untuk graph yang sama, set 1, 2, 4, 5, okay, is a total dominating set. Okay, with the minimum cardinality. Okay, so kita lihat di sini bilangan set S adalah 4. 1, 2, 4, 5 kan ada 4. So cardinality of S adalah 4. Then gamma T adalah 4. Alright. Then ada juga the definition of Roman domination number. Saya mungkin tak sempat ni, saya skip lah. Ada konsep Roman dominating function, Roman dominating number. Ini ada contoh untuk faham macam mana kita boleh dapat Roman domination number. Okay, and then ada satu lagi nama dia Italian domination number. Alright. Dia tak Italian domination number. Maknanya untuk satu graf G tu kita boleh cari domination number, kita boleh cari total domination number, kita boleh cari juga Roman domination number, dan kita boleh cari juga Italian domination number. Okay, so ini adalah sebenarnya 4 contoh domination parameters in graph. So ada banyak lagi domination parameters lah. Kalau nak tahu domination lebih detail, kena baca buku domination in graph yang saya share tadi. Alright. Okay. Okay, then topological indices and domination parameters. So tadi kita dah cerita topological indices, and then juga selepas tu saya cerita tentang domination parameters. Alright. Jadi mungkin kita terfikirlah research sebenarnya kita how to relate lah, macam mana nak relate topological indices, how to relate topological indices and domination parameters for a graph. Okay, then we need to study relationship between topological indices and domination parameters for graph. Okay, a parameter or invariant of graph G is a just now I keep saying domination parameter kan. Domination parameter tu apa kan? So parameter or invariant of graph G is a number associated with graph G which has the same value for any graph isomorphic to G. So this invariant may help us to distinguish non-isomorphic graph. So kalau belajar graph theory, nanti belajar tentang isomorphism in graph. Alright. So some common graph invariant are the number of vertices and edges, maximum or minimum degree, diameter, Gauss independent number, chromatic number, domination number, and etc. There are many more. There are many more graph invariant. Okay, so relationship between various topological indices and domination parameters have been the focus of interest of researchers for many years. All right. Okay, so preliminaries or motivation. So of course, before we start doing research, before doing research on this direction, we need to refer some papers as a motivation. Okay, there are some papers for our motivation. Here we have a paper, Zagreb Indices of Trees with Given Domination Number by Borovikanin and Fortula, 2016. Okay, and then paper on Randy Index for trees with given domination number by Bormudo, Naples, and Professor Juan Reda. Okay, Profesor Bormudo ni saya tengah berkolaborasi dengan beliau dalam satu paper research tapi tak siap lagi, tak habis lagi. Alright, then more papers, Sobot Index of Tree with Fixed Domination Number, published 2020 ini published tahun lepas, Sobot Index with Fixed Domination Number. Kemudian there are many papers on the relationship between topological indices with domination parameters. Tapi mostly they relate topological indices with domination number. Alright, so there are more paper, harmonic index with for trees with given domination number. There are more papers here. This is our publication. Saya nak continue ke? Dr. Sumani. Tak sempat.
Boleh je.
Boleh je? Okay. So we have we publish some papers on this research direction. Okay, so we publish di tahun dalam jurnal AIM's Maths. So AIMS Maths is the Q1 journal. Okay, the second paper we publish in mathematics, minimum Randy Index with three with fixed total domination number. Mathematics is a Q1 journal. Okay, and then the third one we publish in the title is maximum second Zagreb Index, 3 with given Roman domination number. We publish in journal in Iran, transaction in combinatory. It is a transaction in combinatory is Scopus. Then we have Iranian Journal Math Chemistry. So Iranian Journal Math Chemistry is a Scopus journal. So when we Iranian Journal Math Chemistry, the very sad news for the mathematical community, especially researchers in group theory and mathematical chemistry, because hari ni berapa, 12 Januari 9 Januari baru ni Professor Editor in Chief Editor of Iranian Journal Mathematical Chemistry, Profesor Ali Riza Ashrafi, dia meninggal, dia accident kereta di Iran.
Allah, innalillah.
So very sad lah. Saya editor jurnal ni, dia editor in chief editor, saya one of the editor of Iranian Journal Mathematical Chemistry. So very sad news lah. Because last year dia present dekat ISPAM punya apa seminar ISPAM. Saya
online tu.
Online seminar, saya yang jadi ni. Saya minta dia present, so dia present itu. So for few days dia ni so kita sedih jugalah. So dia adalah the well known famous professor in mathematical chemistry and group theory as well lah. Kalau Profesor Haniza Sarmi tu dia kenal lah because as a Professor Ali Riza Ashrafi is a famous mathematician. So saya pun sedih jugalah. Right. Kemudian kita ada satu lagi paper on kita publish dekat communication combinatorial optimization di jurnal dekat Iran juga, Scopus lah. Alright. Ni tak ada, ni tak keluar. Ni paper saya lah. Saya share ya. Just for sharing lah. Tak ada apa lah ni. Ni paper, ni very technical lah, saya skip lah. Ni memang kita dapat upper bound and lower bound for kita study, kita relate first Zagreb index with Roman domination number. So people might ask why we relate, why we study first Zagreb index with Roman domination number. So I can let me share this way ya. Sebabnya macam ni sebab ada paper dia relate first Zagreb index dengan domination number. Okay, itu first paper tu siapa yang saya dah lupa sama ada Profesor Bormudo ataupun Profesor Sergio lah. Mereka study relationship between Zagreb index dengan domination number. Kemudian the next paper from Professor Dus Ali Mojdeh, mereka obtain the result on Zagreb index with total domination number. Jadi saya cadang dekat student lah, kenapa tidak kita consider, kita study relationship between Zagreb index with Roman domination number. Okay. Dia macam tu sebab domination number ni dia ada banyak variasi. Yang pertamanya domination number, lepas tu total domination number. Kan? Jadi Roman domination number, sebenarnya Roman domination number in domination theory dah ada banyak papers. There are a group of researchers who are very good in domination theory from Iran. For example, Professor Nadir Jafari Rat, Professor Sheikhul Islami, Professor Dus Ali Mojdeh, Professor Hind, Professor Hendertini, Professor Henning. Mereka sangat bagus dalam domination theory, tapi mereka tak tahu topological index, topological indices theory. Jadi saya research ni, bidang ni masih baru. So saya cadang kepada student supaya relatekan Zagreb index ataupun ada topological indices with Roman domination number. So alhamdulillah kita dapat completekan the result lah on the Zagreb index dengan Roman domination number. Kita dapat upper bound and lower bound juga. Ini upper bound. Okay, and then kita juga dapat lower bound. Ini lower bound. Lower bound ni kita publish dalam jurnal tadi communication in combinatorics and optimization, in short CCO. So kita dapat completekan lower bound and upper bound and lower bound for first Zagreb index with Roman domination number. Right? Okay, ini yang current work with Professor Sergio Bormudo dan juga Dr. Fatimah. Saya tadi di sini dalam bisa ni tak ada student, tak ada. So saya buat dengan ni lah. Professor Bormudo dengan Dr. Fatimah. Kita relate geometric arithmetic index dengan total domination number, tapi tak siap lagi. Research ni kita ada masalah sedikit. Dia punya proving tu ada mistake. But then kita improve, kita sedang improve lah sekarang ni. Okay, so possible adalah some possible future works. And then ada survey kalau nak study more on topological indices. Ini adalah beberapa survey Okay, saya itu sajalah kok. Right, this is I end my presentation. Thank you.
Terima kasih Dr. Roslan. Cepat nah. Terima kasih Dr. Roslan. Okay, any question from the floor about this topic? This topic is about domination, topological index and domination number. Any question from the floor? Assalamualaikum Dr. Zainuddin.
Waalaikumsalam.
How are you?
Alhamdulillah.
Alhamdulillah.
Very interesting talk. Very interesting. Really good. So just I have some
in another way,
clarification.
he is marketing himself.
Dr. Roslan, thank you very much. Really very interesting talk. Just for me, I didn't get the ending of your first problem. You said that the first problem actually many people couldn't solve the first problem, which is starting from the one point and
history of graph theory.
History. So who solved it, that problem, and
no.
how they solve it actually? Just
actually
can you give the general idea?
This Professor Euler, this problem has no solution.
Until now?
You cannot solve the problem. The problem is impossible. But then he introduced the concept of graph to generalize the problem, to tackle. But normally you cannot solve it. You can try. You can take any. You can take any point here, either A, B, C, or D. You need to find a walk where you just use the walk across the bridges, 7 bridges. You must walk. You must cross all the bridges once and only once, starting and ending with the same point. You can try. It is just a game. Because some say that graph theory started by a game. Very interesting in graph theory.
I see. Actually, this problem is unsolvable problem, and it is already proved this problem cannot be solved analytically, generally, right? Just as a problem until now, still nobody can solve.
No solution.
Okay, because you started from this problem, then until the end, I couldn't understand who solved it. So means it is open problem actually, right?
Yeah, actually the history graph theory.
Okay, good.
No need to solve it because there is no solution.
Okay. Thank you. Just wanted to know the results.
Thank you, Dr. Zainuddin, for the question.
Okay, good.
Very basic question on graph theory.
Yes.
For mathematician that is in this in this domain, who work in this domain, this is a very fundamental question for us. Right. So thank you again, Dr. Roslan, for the topic today. It's very interesting. Actually, it's opened up. Hopefully, it can open up my students' mind on another part of knowledge of graph theory, especially on the theoretical part. We are concentrating here in UiTM for the application part of graph theory. We don't dwell further on the theoretical part. That is our lack of the knowledge on the theoretical part, especially on the topic today, that is topological index and domination number. So based on the Dr. Roslan's presentation just now, so actually I pick up the few problem that we can look into in this topic of topological index and domination number. So basically the problem is we want to find best lower and upper bound of topological index.
Yeah, yes, yes.
Another one is we want to find the relation.
Yes.
Relation between topological index, different topological index with different domination number.
Yes.
Right. So you are concentrating on the theoretical part today, not on the application part. For example, if we have the lower and upper bound of the topological index, what is it for? In the explanation of the physical property of the chemical, chemical molecule, for example.
Actually, if we want to know about application of topological indices, it's nothing to do with the bound. It's a bound problem. Lower and upper bound is a analytical part or fundamental problem, fundamental issue. But if people ask about application, you need to go we need to check the predictive ability of all the topological indices. That's the application part of topological indices. It's nothing to do with the bound, with the axial structure, with the relationship. That one a different domain.
What I am understand is that if actually mathematics can give us a generalization of something, right?
Yes.
So if what I am understand is that if we have the information of lower bound and upper bound of the topological index, we can use this to conform the result of research on predicting some physical chemical property. For example, in the for example, one chemist doing a research on the chemical molecule property, and they are come up with one certain number, for example, one number, and this number is in the bound of the topological index that we mathematician work out. Is that the one that?
So actually, I don't know how the upper bound and lower bound we can relate to the application of topological indices. So far, I don't know. Because the bounds problem is just to characterize the graph. It's nothing to do with the application part of topological index. Because in topological indices theory, there are two domains. Either you go for application or you go for mathematical properties. Application means all related to predictive power of that particular topological index. Because application, we need to find which index is the best predictive power. But we need to.
But how do we know that the result is the best predictive power if we?
You need to check, like, for example, you need to check, like, you take one molecule, chemical molecule such as octane, and then you test for all the 16, maybe more than that, all the
possible
chemical physical properties. And then but we need to study more, and then you need to test all the index for all the 16 properties and check the correlation. And then you need to know the prediction theory or forecasting or something like that. But so far I don't know the bounds can be related to application.
Okay, I understand that one. So actually, whatever that we have found here as a mathematics research on this topic, so we can look into the conformation by looking at this result into the, for example, octane just now we have 16, so we test one by one. Right, I understand that one. Okay. Students from the floor, is there any question you want to ask about this topic? Of course, this is a new topic, but hopefully it interests you to know more about graph theory. Maybe you might want to do a master program or master research with Dr. Roslan. You are encouraged to do so because he is more knowledgeable than me, inshallah. Any question, student? Is you like there's no question, Dr. Roslan?
Tak ada soalan.
Ada soalan ya. Okay.
Dia belajar dah ni kan? Dia dah belajar graph theory kan?
Actually diorang dah belajar graph theory tu dah towards the end akan masuk kepada graph coloring nanti. Sistem yang you guna seperti macam event itu dia memang familiar lah. Macam isomorphic tu dia familiar. In fact dia pun ada cara untuk tunjukkan dua graph tu isomorphic with what method lah.
Graph coloring tu ada belajar apa namanya chromatic polynomial.
Yeah. Ada belajar, adalah kita sentuh introduce sikit macam mana nak dapat chromatic polynomial for a graph yang common graph.
Because chromatic polynomial tu dia asalnya dia nak solve 4 color problem. Kan famous problem in graph theory kan.
Yes.
Tapi tak boleh solve pun.
Memang.
Tak boleh solve 4 color problem, but then the chromatic polynomial of graph tu keep expanding lah, dia jadi satu research.
So nanti untuk next webinar kalau Dr. Roslan nak sentuh on the research of expansion of chromatic polynomial, mungkin bolehlah sebab belajar
boleh juga sebab kalau nak cerita pasal graph coloring memang saya buat research dulu kan, saya buat chromaticity of graph tu memang relate dengan chromatic polynomial of graph lah.
Yes, boleh kalau kita nak buat second webinar on that topic. Sebab student ni nanti saya akan introducekan dengan apa dia punya common term dalam graph coloring.
Okay. Mungkin next talk kita bincang pula pasal
ya boleh.
Polynomial kan, 4 color problem. Itu lagi famous tu 4 color problem in graph theory kan.
Betul. Alright, so kalau macam tu saya ucapkan terima kasih kepada Dr. Roslan untuk komentar tentang ini. Very good knowledge for the student insyaAllah, and for me as well. Thank you very much, and we will continue the webinar on second part insyaAllah on the graph coloring.
Graph coloring, okay.
Terima kasih Dr. Roslan.
Minta maaf kalau ada kekurangan.
Okay, terima kasih banyak-banyak.
Baik, sama-sama.
Okay, Assalamualaikum.